So here we're basically going to discuss Malus's law, and we are going to verify Malus's law using a pair of Polaroids. So what are we doing here? In the apparatus in this figure we can see that we have an LED light source over here. Okay. After that we have two Polaroids, this and this. This Polaroid is basically known as my polarizer. This Polaroid is known as my analyzer. And over here I have a photodetector. Okay. So what is this photodetector doing? This photodetector is basically converting the LED light into current. Okay. And this basically is a microammeter that is connected here. Fine. Now what will we do? We have basic apparatus setup that is of Malus's law. Now of course the formula that is being used is what? IT is equal to I naught cos square theta. Okay, IT is what? Intensity of light transmitted through the analyzer. I naught is the intensity of incident plane polarized light, and theta is the angle between the axis of the polarizer and the analyzer. Now what will we do? First step is that we will find that there are two screws over here in the polarizer as well as in the analyzer. Now these screws that will be there, we need to turn these screws. What will happen? The height of these Polaroids can be adjusted using those screws. So what am I doing? I am turning those screws in such a manner that both the Polaroids are having a height which is reduced. So they have their heights. Now currently the height is over here. So now after that, when I am rotating the screw, I will drop these Polaroids. So why will I drop these Polaroids? I will drop these to ensure that light from this LED source is directly moving and falling on the photodetector. Okay, I want to see that. I want to test that how much light, how much current is being produced when directly from my LED source light is falling on this photodetector, and I will see from here the value of that current. Okay, this is how I will do. Once I have done that part, I have noted down the current, direct current that is coming from LED to the photodetector without any Polaroids in between. Once I am done with that part, what will I do? I will now slowly take this Polaroid, that is my polarizer, and I will lift it. Okay. Now one more thing that I would like to mention here is that on this particular photo detector, you will find that if this is my photo detector, over here there is a small dot. Okay. So the light which is falling from the LED that is coming, it should directly hit this particular dot position. Only then will we be able to find that maximum current is being detected, and that can be measured through the microammeter that is connected here. So the light which is falling from the LED must fall onto this dot of the photodetector at the center of the photodetector. This is a very important criteria. Once that is ensured, what will I do? I will now, so basically let me do one thing. Let me just take this and let me just hide this. So now I have done what? I have increased the height of this polarizer in such a way that the light which is coming from the LED source is passing through the center of this Polaroid and it is moving out. Okay. Now on this Polaroid, on this polarizer, there is a circular scale. Okay, like a circular scale, lot of readings are mentioned in that circular scale. So there is a circular scale and there is a rotator, so that you can rotate using your fingers. So this circular scale, it is 360 degree. Okay, so angles 360 degree, and there is a pointer on that. So you can see, okay, I can't mark it here. So there's a pointer over here that is there, and that particular pointer, once you're rotating the scale, the rotator, that pointer will rotate along with it, and that pointer will mark out that particular angle that you are pointing to. Okay. Now once that part is done, what will happen? You have to see now at what particular angle is the light maximum. Now see, remember this, there is no analyzer now, there is only a polarizer here, no analyzer currently. We have pulled down the analyzer niche. Okay, there's no analyzer here. So when light is falling on this polarizer and it is passing through it, and it is going to go straight over to the detector, to the photodetector, like this. Now what is happening? We are measuring the angle at which I am finding maximum current. So what will I do? I will rotate this rotator that is there with my fingers, and I'll keep on changing my angles. And once I'm changing my angle, I will be able to see that the current that is being shown over here is constantly changing. And at a particular angle, I will find the value of my current to be maximum. I will note down that angle. This is the angle of the polarizer, okay, at which it has been set. After that, what will I do? Now I will forget about everything. I will now lift this. Okay. So once I have lifted this, now one thing that needs to be kept in mind is that try to see that these two, that is the analyzer and the polarizer, are more or less parallel. So here you can see that these are not parallel, but ensure that these two are parallel, of the same height. Okay, if possible. That is possible, but at least get closer to it as much as possible. Okay. Now once that is done, now I've lifted this analyzer as well. So what is happening? Now light which was coming from here, the LED source, was passing through the polarizer. Now it will move through the analyzer as well. And it will move out and it will fall on this photodiode at the center. Okay. Of course, what is happening? Since there is another pair of Polaroid here, obviously there will be a variation in the intensity of light. First polarizer intensity is getting reduced by a factor of 1/2. And of course, over here also there will be variation. So what is happening? Now I will again change the angle. Here also, in this particular analyzer, we are seeing, or in this Polaroid, there is again a circular scale with a rotator and a pointer attached to it. Okay, now again I will rotate this rotator, and I'll constantly keep on rotating it, and at a particular angle I'll find that now my current value, at whichever angle my current is maximum, I will note down that value of that angle as well as the maximum current. So what am I doing? I am rotating this. I am seeing that okay, there is one particular angle at which my current is maximum. The current is maximum, very good. Also the angle which is there, I'll note both these down. So I'll note down the angle, I'll note down the current. Done. Now this is the basic setup that we have. Now what you have to do is, there are two methods of doing it. Number one is, say for example, I am using some random figures. Now if I just get to the table here, I'm using, this is a nice diagram that we have. Now I am using this table here. So I have noted down first, here I will do what? I will note down the angle of the polarizer. I'm sorry for the bad handwriting, but anyways. So this is how we will write down the polarizer angle, whatever angle we have. Then angle of analyzer, when current is maximum, we are writing it down. And then we have the maximum current that we have for when I am lifting both these two. So my light is coming from here, polarizer, analyzer, and then photodetector, selenium photocell usually. Okay, and I will note down the maximum current. So of course this is the table now. First we will do what? We will write down the angle of analyzer phi. So we are starting off from this phi naught. So say for example, my phi naught is coming to be 210 degrees. So over here I will write down 210 degrees. Okay. After this, what am I doing? I am measuring the current, which is equal to the intensity, because current is directly proportional to light intensity. Light intensity cannot be measured directly. So hence we are using current, okay, to measure the intensity that is there. Now here what will be my current? So I am going to measure, write down the corresponding current that I am getting. Say for example, the maximum current over here I got is 62 milliampere. Say for example, I am using micro, I apologize. So say it is microampere, 62. So what am I doing? I am going to place 62. Now what is theta? Theta is phi minus phi naught. What is phi? Phi is 210 degrees. What is phi naught? Phi naught is the angle of analyzer when current is maximum. That is phi naught, which is also 210 degrees. So 210 minus 210, that is 0 degree. Okay, sorry. Let me do one thing. I apologize. Okay. So here it will be what? Let me put it down. Very good. So here it will be what? It will be 0 degrees. Okay, so this one is done. Next value. Now when I mentioned two methods, I can do what? I can increase the angle from 210, I can make it 220, 230, 240, or I can also decrease it. That is 200, 190, 180, anything. Now I will keep on decreasing my angle of analyzer. So I'll say make it 200, I'm decreasing it, say. I'm making it 190 degrees, I'm making it 180 degree, whatever. I'm slowly reducing the values. Okay. And corresponding this will do what? This difference will keep on increasing, obviously, because 210, say I have to constantly minus 200 from 210, 190 from 210. So obviously this difference will keep on increasing. If I am decreasing this will increase. So 30 degree and so on and so forth, it will go on. What will be my current trend? My current trend will decrease. It will go down. Okay. Why? What will happen? If I get to the basic formula, I is equal to I naught cos square theta. Now my cos theta, when my theta is 0 degree, my cos theta value is maximum because cos 0 degree is 1. So I'll have maximum current then. When my theta is equal to 90 degree, my cos theta value will be minimum because cos theta is equal to 0. So my intensity will be 0 or minimum, whatever. So obviously when my theta is small, that is theta is 0 degree, my intensity will be maximum. As I'm increasing my theta, obviously my intensity will drop. It will drop in such a way that for a particular value, I will find that my current is 0. Okay, my current is 0. Now this will not just be for a particular value. We will do what? We will take a couple of angles. Then we will reduce the difference. That is, what will we do? Say for instance, for example, I am getting a 0 degree at say 135 0 current at 135 degrees. I am getting this. Okay, so what am I doing? I am going to now take the next angle, that is 136 degree, 137 degree, and I will constantly take a couple of values because that will be easier for me to show in the graph. Okay, so I'm getting 0, 0, 0, and then I'll see what? Again there is an increase in the current. Again there is an increase in the current. So it will go up. Okay, so this will continue. Again there will be a point where I will see that my current value will start to drop because my theta is, remember, it is a 360 degree angle circular scale. 360 degree circular scale. So one time it will be maximum, it will again go minimum, again it will rise to the maximum, again it will come down to the minimum. So this will continue for a while. And we have to continue taking readings till the time we again reach 210 degrees. Okay, so it is a full 360 degree cycle that we are completing. Full 360 degree cycle that we are completing. That is what we need to ensure. Okay, so the graph then will come up like this. That is, this is your current, this is your angle theta. You can see in the scale, if I just zoom in a notch, it is 0, 40 about, 90, this is 180, 270 to 360. So you are seeing at 0 degree, my current is maximum because cos theta is maximum. Okay, or cos square theta is maximum. Then at 90 degree it is dropping. Why? Because my theta, when it is 90 degree, cos theta is 0. So it is dropping to 0. Again it is rising 180 degree. 180 degree, my cos theta value, cos square theta is 1. Cos theta minus 1. Cos square theta 1. So maximum intensity. Again it is dropping 270 degree. Cos theta value, which is there. So it will be minimum. So theta value for 270 degree, cos theta 0. It is dropping to 0. Again it will rise for my 360 degree. So we can see this particular curve that is taking place. Now there was another column over here that was theoretical that we had done because this is a theoretical value that we have. What are we doing in this theoretical value? We are basically mentioning 62 because say for example it is 62 maximum current, 62 into my cos square theta value, whatever I am getting. So theta is this, you find out cos theta, cos square theta, whatever value is there, you put it here. And you will get the corresponding theoretical value. Now in this graph we are again drawing I experimental, whatever current value we got versus cos square theta, and we will see that the graph will be a straight line. Okay, so this is one curve, that is I experimental versus theta curve, because I explained the intensity thing. Here we are seeing what this is I experimental versus cos square theta. This is a straight line. Okay, so this is how this experiment will be performed. You have to keep in mind that my intensity of light that is coming from the analyzer is maximum at 0 degree and 180 degree, and is minimum at 90 degree and 270 degree. It is very simple. Just ensure that you remember this expression: I theoretical is I maximum cos square theta, or IT is I not cos square theta. So it varies, it completely depends on this cos square theta value. So theta, if it is obviously 0, 180, cos theta will be maximum. If theta is 90 degree or 270 degree, cos theta will be minimum. So my intensity of light and indirectly my current will also be minimum. So this is how this experiment is performed. Thanks for watching. If you have any doubts, please ensure that you put it out in the comment section of my video. And make sure that you like, share and subscribe, and hit that bell icon out there for future updates.